All right, boys and girls, last video for day 1, and I'm actually going to combine example 4 and example 5 because they go together, okay? These are horizontal translations. So horizontal translation basically means like a shift moving left or right. Okay, so now I added another variable to our equation. So now we have y equals a sine of bx minus c, or you could get y equals a cosine of bx minus c. So we already know that A is our amplitude. Our B will help us find our period. And now our C. And remember, B is going to be a horizontal stretch or shrink. And then C is actually going to help us with our horizontal shift. It tells us if it moves left or right. Okay. Again, these are kind of similar topics to integrated 3. So kind of a heads up, if your equation is negative, if you plug in a positive value, it's actually going to shift towards the right. And if you plug in a negative value, then it's going to be plus C, which means your C is negative, it shifts to the left, okay? And I'm sure I'm going to show you an example of that, okay? So basically, two equations are given, bx minus c equals 0 and bx minus c equals 2 pi. And this will help you solve for x, and it's basically going to help you with your range, okay? I'm sorry, not your range, with your domain. Basically, how far to the left you go and how far to the right you go. So it's similar to your period now, okay? So here we go. Which is actually going to help you with your intervals, okay? So remember in the very first example, they gave us our intervals, our first interval, and then after that, I said, oh, they're not giving us an interval, so let's just stick to 0 to pi. Now with this, it'll give you your intervals, okay? So to get your domain, this is kind of like the basic formula. C over B is going to be our minimum, and our maximum is going to be C over B plus 2 pi over B. Okay? Probably doesn't make any sense now, but it'll make sense in a minute. Okay? All right, let's go straight to our first example. Okay, here we go. I'm going to do the extra example because I think I'm going to give you guys the checkpoint on example 4 on page 296. So basically the directions are to analyze the graph of y equals 2 sine of x minus pi over 2. So now we're going to put so far all the different things that we know. Okay, so here we go. We know that our, let me color code this so it stands out. Okay, we know that our A stands for amplitude, and that's the absolute value of 2, which is 2. And remember, this helps you with your range. So your range is going to be greater than or equal to -2 and less than or equal to 2. So that's that, okay? And then let's find our period. So our B is actually going to be 1 right here. Because remember, let me write it down so you know. A sine of bx minus c. Okay, so our B is actually 1. So to get our period, we do 2 pi over 1, which is just 2 pi. Okay, remember it's 2 pi over B. And that's why earlier I would tell you guys our period is 2 pi when you didn't see a value. Okay, all right, so we have our period, we have our amplitude. So now let's get our intervals. So let me use a different color. So this is when we use our C. Okay, so what we're going to do is we're going to set two equations. So remember, bx minus c equals 0 and bx minus c equals 2 pi, and we're going to solve for x in both cases. Okay, so now I can substitute. B is 1, so I'm just going to write x. C is pi over 2. Okay, equals 0. So over here it's going to be x minus pi over 2 equals 2 pi. Remember, our equation is minus c, so our c is just pi over 2, okay? So let's solve for x. So here, x is just going to be pi over 2. Over here, x is going to be 2 pi plus pi over 2. Let's get common denominator. So now we're going to have 4 pi over 2 plus pi over 2. And that's going to give us 5 pi. Okay? So how does this help us? This helps us with our interval. That means our interval should be starting at pi over 2 and ending at 5 pi over 2. Remember, our interval is the same as our domain. Okay? All right, so we're analyzing this. We have amplitude, we have period, we have our interval. Now let's get all those points in between, okay? Okay, since our interval started at pi over 2 and is ending at 5 pi over 2, we know that that's where we're starting and that's where we're ending. Okay, now we need all our key points in between. So that's when we use the period. And we're going to divide that by 4. Which gives us pi over 2. So then we use that to come up with all our key points in between. So take pi over 2 and add pi over 2. And then you end up with 2 pi over 2. And don't forget that 2 pi over 2 is the same as just pi. Okay? And now take pi and add pi over 2. So that'll give us 3 pi over 2. Okay? And then add pi over 2 to 3 pi over 2, which gives us 4 pi over 2. And then 4 pi over 2 is the same as 2 pi. And then add 2 pi and pi over 2, and that's the same as 5 pi over 2. So these are all our key points in between, okay? So what are we actually plotting? Okay. So we're actually going to plot, remember this is sine, so we're going to plot pi over 2 and 0, okay? Okay, and then our next point is going to be pi and 2. And then if you're wondering, how did I get 2? Remember that our first point started at 0, 0. Okay, so, but then our next point is starting at 0, 1, but then our amplitude is 2, so we're basically multiplying it by 2. So that's how we get pi over 2, or pi and 2. Okay, and so our next point is going to be 3 pi over 2. So it's root maximum. So now we're going to come back to our root, so 0. And then after 3 pi over 2, we have 2 pi, and that'll be 2 pi and negative 2. So maximum, minimum, and then our last point, which is 5 pi over 2, is our root. Okay? They didn't ask us to plot, so we're not plotting this. They just wanted us to analyze. So these are all the important points. Okay? And then you should be able to plot, and you should be able to graph with all this information, okay? But all this you're able to get it without a calculator. All right? All right, awesome. Let's do one more. All right, boys and girls, I'm going to just continue with the extra example 5. And the reason I'm going to continue is because example 4 and example 5 are horizontal translations, okay? It's just they separated them by a translation going to the left and a translation going to the right. So this is the example that I'm going to do with you. So again, they just want us to analyze the graph. They're not necessarily asking us to graph, but we could. So y equals 2 sine of 3 pi x minus 2 pi. And I went ahead and wrote the general function above so that you're able to identify your values. Okay, so here we go. Let's start with amplitude. So your amplitude is 2. Okay, so a couple things. because your amplitude is 2, that means it's a stretch. It's a vertical stretch, okay? I will write that down, vertical stretch, okay? They may or may not ask you this, but you know that your amplitude will identify vertical stretch or shrink, okay? And remember, it also tells you your range. This will be minimum -2, maximum 2. So y is greater than or equal to -2 and less than or equal to 2. So again, these are all the things I should be able to tell, okay? Your b is 3 pi, and that will help us find our period. So our period is 2 pi over b, and in this case, our b is 3 pi. So if you simplify this, you just get 2/3. So our period is 2/3, okay? And I know this is going to look funny, but they're not asking us to graph. So there we go, 2/3. And so now we're going to find our intercepts. I'm sorry, our interval. So that's when we set our functions equal. Ready? So we get 3 pi of x minus 2 pi equal to 0. Whoops, let me fix that. Okay, and then our second equation would be 3 pi, let me put a comma in between, 3 pi of x minus 2 pi equal to 2 pi. And we're just going to solve for pi in both cases, okay? So here we go. 3 pi of x, or I keep saying of, sorry, 3 pi times x equals 2 pi. And then again, remember we have to isolate x. So this would be x equals 2 pi over 3 pi, which is just 2/3. Okay. And now for the second one. So let's see. Add 2 pi, we're going to get 3 pi x equals 4 pi. And then divide. So we're going to get x equals 4 pi over 3 pi, which is just 4/3. Okay, so this is all the stuff. Let me just show it to you because I'm about to erase it just to clean it up. Okay, so we came up with all this stuff. So that means our interval should be 2/3 and 4/3. Remember, our interval is the same as our domain. So this is our domain, this is our range, this is our period. Okay, all right, let's get those key points now. Okay, here we go. I kind of got a head start, guys. So our period was 2/3, so we're going to divide by 4. So it's the same as saying 2/3 times 1/4, which if you simplify that, that'll give you 1/6. Okay, so we know we're starting at 2/3 and we're going to end at 4/3. Okay, so we're just going to add 1/6. So 4/6, because that 2/3 gets turned into 4/6, plus 1/6 will give me 5/6. Okay, and I'm going to keep doing that until we stop at 4/3. So let's do that. All right, boys and girls, let me wrap this up. Okay, so I went ahead and plotted, or not plotted, but found all the points off camera. So 2/3, 5/6, 1, because it's 6/6 is just 1, 7/6, and then 8/6 is the same as 4/3. So I know I'm done. Okay, and the points we would actually plot would be 2/3, 0. Remember, our amplitude was 2. So 5, 6, 2. Okay, 1, 0. So it's root, max, root, and then minimum, 7, 6, -2. And then root, 4/3, 0. And that's it, guys. Again, they just asked us to analyze, and I gave you more than enough information. There's probably some of those things that you didn't have to give, but I gave them to you so that you know that just by looking at that, the function, you should be able to write, okay? So you should be able to graph and do all that. All right, boys and girls, we are done for day 1. We will continue next week with day 2, but you should have enough to at least get started on your homework, okay? All right, go ahead and get started and reach out if you need help.